see how they compare. And so from a medical background, I think that wetting agents are oftentimes overlooked in terms of the importance and how you can actually use them out there. And so I'll kind of give you an anecdote or an analogy to me as a physician writing a prescription for my patients. Well, it's kind of the same way with using wetting agents out there on a golf course or lawn care or a sports field. You really have to understand that these are actually kind of like drugs, very similar to your integrated pest management products. And so how do you use them? You have to understand their function, their strength, where they can go wrong, the side effects, and what you're really trying to achieve. And so we'll kind of dive into the nuts and bolts of this over the course of the next hour or so, just so that we can kind of get a framework in terms of where we're going. So this is a golf course. This is actually a golf course in Sydney, Australia in December. So this is equivalent to our July, heat of the summer. Australia has some of the worst sort of drought and LDS pressure that we can see. This happens to be a fairway. As you can see, one side has some sort of browning grass, the other side does not. And interestingly, the only difference between these two sides is that there was a soil wetting agent applied to the right side, and on the left side, it was just irrigation alone. And just by looking at this, this looks a lot like localized dry spot, but you really don't know that for sure. And so we'll come back and talk a little bit more about how you can actually diagnose really simply, very quickly on your golf course if you have something like this. How do you actually know and prove that this is localized dry spot and that a soil wetting agent can really achieve what you need to do? But you can see here, really nice uniform conditions with the soil wetting agent versus the irrigation alone. And so what is going on the localized dry spot area is that you develop water repellent soils. And what happens is these areas of dryness, the water actually can't infiltrate into that soil because there's a water repellent coating around the soils, and this is really problematic. And this leads to what's called fingering of the water. So only areas where you can actually have water infiltrating into the soil is where the water actually runs and goes. And so what we really want to do is really convert this water repellent soil over to a wettable soil. And we can do that with a soil wetting agent. And this wettable soil, you can see the distribution of water going into the soil is very, very uniform. And if you think about all of your products that you're adding into your turf, your nutrition, your integrated pest management products, what is the carrier that you use to apply them? Well, it's water. And so if your water is not uniformly going into the soil, it's not just the water that's not going in uniformly, it's also your nutrition, it's also your integrated pest management products, all those things really key to keeping your grass really nice and healthy. So wetting agents are really critical out there. And I'm sure most of you who are listening here are using them. So this is one of the lab tests that we can use. And so you can see there's a soil wetting agent. We're going to put 5 drops of either water alone or this soil wetting agent onto the sand, and then kind of spread some water over the top of this. And you'll really see that the wetting agent doesn't have any problem with getting the water into the soil. The water alone, the water can't even penetrate into this soil. It's just sitting right on top. The water that's added on the soil wetting agent side goes really nicely, uniformly into the soil, really creates a really nice uniform distribution of that water. The water alone side, this is exactly what happens on your golf course when the water can't get in. It's going to sit on the top, it's going to run off, you're not going to get any water in there. And so this is a big, big problem if you're not using a wetting agent. And you can see the water alone side, there's absolutely no water in there. Soil wetting agent side, you've got really nice distribution of water. So this is really what it looks like. And I think that soil wetting agents are kind of really interesting because everything that they do is under the turf. You look at your turf, you can tell whether it's healthy or not, but you can't really tell whether your soil is healthy or not. You can't tell whether it's uniformly wet or not. And so I think it's really interesting to see some of these lab tests and kind of equate what's going on in the soils to the application of these wetting agents. Now you have some tools that you can use, and so you can take cores. You also can use your volumetric water content, TDRs, to measure soil moisture, see how uniform the conditions are. And so those are some of the tools that you're going to be able to use to see whether you need a wetting agent or not. So I just showed you some sand, but sand is not the only thing that can become water repellent in the soil. Organic matter can also become very, very water repellent as well. And so the way that we do this in the lab is we can take some peat pellets. These peat pellets are incredibly hydrophobic. And you can see the water alone, there's no water infiltrating into this peat pellet. Whereas if you have a soil wetting agent here, very, very quickly will wet that organic matter very, very uniformly, sucks that all of that water all the way up into that organic matter and really allows that to expand. And so this is another key to wetting agents. Not all wetting agents are going to treat your organic matter, and almost all turf, unless you've got a brand new green where you haven't incorporated any organic matter into it, it's going to have organic matter in it. And certainly over time, all golf course greens are going to have this organic matter. And so really a critical key to your soil wetting agent, you want one that can really treat this organic matter too, because this can also become very severely water repellent. So localized dry spot, we talked a little bit about this already. And so the real question is this turf damage, is this turf stress caused by a localized dry spot? Just by looking at it, maybe you can tell a little bit, maybe you have some suspicion, but to really prove it, what you need to do is you need to take a soil core. You can take this soil core, lay it on its side, and put water droplets onto this. You can even put the water droplets at different depths. And if the water droplet takes more than 5 seconds to go into the and infiltrate into that soil, that is a hydrophobic soil. And so there's actual hydrophobic soils where you can do it right away. You can also dry it over time, over the course of a week or two. And if the water droplet takes more than 5 seconds after drying that soil core, that's potential localized dry spot or hydrophobic soils when you really sort of dry things down. And so you can calculate both of those things. And so here's a picture of this water drop sitting on top of the soil core. You can see that we've done this on different depths in the soil. And so this is really great. You can tell exactly what depth in terms of where your hydrophobic soil actually is in these different conditions. And so this is really important because if you're going to apply a wetting agent and you have hydrophobic soils, maybe 2-3 inches down into your soil core, and you only water your wetting agent in an inch, well, it's not getting to where it needs to go. And so this is really a diagnostic test, but it can also help you to understand how far or how deep do you have to water that wetting agent in to make it actually get to the places where it needs to go. So here are some things that cause or are problematic with soil water repellency. We already talked about preferential flow and that fingering effect. This preferential flow is going to create poor moisture uniformity. So if you're out there with your pogo or your TDR and you have a lot of uneven distribution of moisture over your green, you're going to have some wet areas, you're going to have some dry areas, you're going to have some areas that are really kind of straight on or on point in terms of the volumetric water content. Well, that means that there's really poor uniformity of that moisture distribution. You're going to have to overwater some areas and underwater other areas just to keep your grass alive. And so this is really problematic and will push you to over irrigate. Maybe you have to get out there hand watering. Labor is an issue, so hand watering is really tough. And so to overcome this poor moisture uniformity, what you really and poor and inefficient irrigation, what you have to do is to apply soil wetting agent. And so these are some of the keys that we talk about all of the time. So this is a map that I follow kind of every single week. This comes out on Thursdays here in the United States from the US Drought Monitor. This is the map from yesterday. You can see much of the United States is in a drought. Not all areas of the United States are in a drought, but we're in February, we're in the winter. And so you can imagine what this may look like in the summertime if we already have pretty severe conditions out there in terms of drought. But just because we have a drought doesn't mean that there's problems in terms of the amount of soil moisture. And so the other thing that I love to follow every single week is the what comes out of Syngenta's Greencast Online. And this is the link that you can get to. You can also search that US Drought Monitor so that you can continue to monitor for your area around the country as well. But here on this Greencast Online map, this is the areas of the country where there's poor soil moisture or low soil moisture compared to high levels of soil moisture. So you can see the areas that are kind of bright purple to blue. These are areas where the soil is saturated, there's high volumetric water content. Then you go all the way over to the yellows, the oranges, the reds. Those are the areas that are very, very dry. And so you can see in kind of sort of the southern Midwest, Texas, New Mexico, Arizona, Southern California. This is our desert. So you can imagine that in the desert, you're going to have low soil moisture. And that's exactly what we see here. But there's some other interesting things that kind of catch my attention almost every single week. And that's that Florida, hugely dry soils here. It's surrounded by water, lots of wind. And so there's dry soils there. And then all up along the eastern seaboard, again, not as bad as the desert, but there's also dry conditions there as well, all the way up into Massachusetts. And again, this also has to do with the wind and the rainfall and all those sort of things as well. Those microclimates in those areas can lead to situations that are going to set you up for dry conditions and localized dry spot. Also Michigan, another hot spot all through the year. So again, we're in February, and so we're already dry in a lot of different areas. So you can imagine what's going to happen potentially in the upcoming months as we start to get hotter weather, higher evapotranspiration rates, and differing weather patterns as well. So again, back to the effects of localized dry spots or soil hydrophobicity, lots of different things. I'm not going to bore you in terms of reading through each one of these or dialing into each and every one of them, but just to suffice it to say, there are lots of different problems that come with soil hydrophobicity. That's the reason why almost every golf course on the planet uses soil wetting agents. And so this is really exciting for us as manufacturers of these wetting agents. These are really critical problems that we have to develop really innovative technologies to be able to help you guys overcome exactly what you need to overcome. So where does this soil water repellency come from? Well, what we believe is going on, this is an electron micrograph of the surface of a sand particle. And you can see there's areas where there's almost like a coating over this. We believe that these are organic coatings over these sand particles and soil particles that leads to the soil hydrophobicity. And so where do these organic molecules come from? Lots of different places. And so we've got waxy plant leaf coats, decomposing plant material, microbial byproducts. And one of the things that you may have heard, I was down at the GCSAA conference down in Orlando last week, listened to a wetting agent talk down there. These plant root exudates, when they dry out, they help to kind of pull water in when the soil is wet, but when they dry out, they can become very, very hydrophobic and are probably one of the major causes of soil water repellency as well. And maybe you saw that surfactants can overcome some of those problems as well during that presentation if you were there. But suffice it to say, again, these are really important things in terms of what's contributing to the hydrophobic soil conditions and soil water repellency. So this is what the organic molecules actually look like. So we have hydrophilic or water-loving parts of the organic matter, and that those organic matters also have some hydrophobic or water repellent parts of it as well. And so this is what sort of the molecule actually looks like. If this molecule sits down on a sand particle, it will actually coat this entire sand particle or soil particle, exactly what you were seeing on that dried sand particle on a slide before. And this is exactly what's happening. The hydrophilic or water-loving side of these organic matter molecules will bind to the surface, exposing the hydrophobic surface. And if you coat this entire sand particle with a hydrophobic surface, this is going to be really problematic. This sand particle can't be wet. And that's where wetting agents come in. Wetting agents also have hydrophilic or water-loving and hydrophobic or water repellent parts of this molecule. And so what happens is when you have a sand particle or a soil particle coated in this hydrophobic surface, we can bring a wetting agent in. That water repellent or hydrophobic part of the wetting agent is going to sit right down on the surface, and the water loving tails of this wetting agent are going to kind of float out on the surface. And you can imagine that this wetting agent is now going to coat this sand particle and allow water to coat this sand particle again. This is exactly what's happening. This is why we can convert a hydrophobic sand, add a wetting agent to it, allow that water droplet to spread out over the sand and allow that whole sand particle to be wet again. So this is the kind of the molecular dialing down very, very microscopically into what's actually going on a molecular level for these wetting agents, and this is how they work. So that's kind of the science behind these molecules. And so that's what I wanted to really talk about in terms of the biology and the molecular sort of aspects of it. And this is the agenda that I have kind of set out for the rest of the talk, now that we have the introduction done in terms of the benefits and the mechanisms of how these products actually work. So I'm going to start the rest of the presentation by really diving into what the current state of the wetting agent market really looks like. Then we'll go into kind of product differentiation. There's hundreds of products out there. How, as an end user, are you supposed to choose between these products? And that really dives into, well, what does it show in the lab? What does it show in the field? And so we've really dialed in our understanding of these products over the past 5, 10, 20 years in terms of really bringing you information that's really critical for what you really need to do in terms of being able to apply these in the field. And then we'll come back to, once we understand what these products are doing, how do we write a wetting agent prescription for your course? And we can talk maybe in the question and answer time frame in terms of what we can actually do and how to, what are the nuts and bolts in terms of actually doing that. So just a couple of additional anecdotes out there. We can show, this is a golf course green. You can see these areas that look pretty healthy on the green and just around the collars here too. These were treated with a wetting agent. This happens to be an unirrigated green over in Northern Europe. And you can see those areas where it's not treated with a wetting agent around the bunker here. There's and over in the rough, kind of in the background, there's a lot of turf stress here. And for an unirrigated green, this is pretty amazing to be able to apply a wetting agent. And again, this is about a 4 ounce per 1,000 square feet application. This is a pretty amazing effect. And so when you compare a wetting agent to an untreated area, these wetting agents are really showing that they can help in terms of maintaining really much nicer turf grass quality compared to those areas that are not treating with a wetting agent. And this is not just the greens. We can look at a fairway. Again, this is an unirrigated Northern European golf course here. Half the golf course was sprayed with a wetting agent on the right, half of it was left untreated. And you can really very clearly see that these wetting agents are having major benefits to the turf grass here, allowing much more uniform conditions here, mainly because you're getting not just the water evenly distributed here, but all of your turf nutrition, integrated pest management products, all evenly distributed throughout this area here. So major benefits, not just on the green, but also on the fairways as well. So this is really great for unirrigated areas, but I suspect that many of you are using irrigation not just on your greens, but also on your fairways. And so we wanted to take this to a very high-end course in the United States and see if we could even see some of these wetting agent benefits on a real live golf course with irrigation all throughout the course. And so this happens to be Royal Oaks Country Club out in Vancouver, Washington, here in the States. This is a golf course run by Gordon Kiyokawa. He is one of our partners and was willing to allow us to spray our wetting agents here on his course. I'm going to get one of my pointers here for a second. There's 2 areas on his course. There's a practice area right here in the middle that had never ever seen any wetting agent ever applied before, and another practice area over here on the left side of the course. You can see the NDVI. This NDVI imaging is kind of showing plant health. And so the areas that are yellow and red, this means that the plants or the turf grass is under a little bit more stress. You can see that those 2 areas on the course are showing a little bit more stress than some of the other fairway areas on the course that are have better irrigation, have more nutrients, have more wetting agents applied, so on and so forth. And so just a snapshot of this course shows in and of itself, wetting agents are having a really nice effect on the main fairways here. But in these areas, these practice areas where there's no wetting agents applied, a real problem. You can also see this over on the red, green, blue images, that this turf grass here, a little bit more stressed, not quite as green as the other areas. And so we wanted to kind of put the soil wetting agents to the test. And so what we did here is spray half of this sort of middle area of the practice area with wetting agent. So this top half top half got wetting agent, the bottom half was untreated. And you can see in the red, green, blue images that the turf grass and the soil wetting agent side is a little bit more healthy. When you look at the NDVI imaging, it's even a little bit more clear that the soil wetting agent treated side of things looks a lot better. Now, this is only a month after or a single application of a wetting agent, and we're already seeing benefits. And this is kind of the April-May timeframe of 2020. And in Vancouver, Washington, this is not the heat of the season. And so in the middle of the season in July and August, this is what the practice area looks like. You can see some major localized dry spot, especially where there's trees, a lot of roots sucking up that moisture. Very, very poor conditions here. Very clear on the NDVI, very, very severe conditions here. When we use a soil wetting agent, we can really preserve a lot of the turf grass health. It's not perfect, but it's a lot better than the untreated side. And so you can even see in the NDVI imaging, here's an irrigation head right here, and the poor uniformity of the irrigation on a couple of these irrigation heads, you really can pick them out very, very easily. But with a soil wetting agent out there, even with poor uniformity of that irrigation head, the soil wetting agent really helps to spread that moisture out, really gets that into the soil and creates much, much better conditions out there. So even on a golf course here in the States with better irrigation, wetting agents are very, very beneficial, even in these large turf grass areas out there on the fairways. This happens to be native soil as well. So when you think about hydrophobic conditions, the sand-based root zones are going to be the most prone to developing hydrophobic conditions because of the fast wet dry cycles that go along with them. Native soils also can develop that, even though they don't have as severe of fast dry wet cycles. And so this just goes to show that think about soil wetting agents, not just for the greens, but really in a lot of different places on your golf course as well. So the last thing that we did at Royal Oaks was the other area of the other practice area. And here, what we did was in September 1st of 2020, they did aerification over this entire fairway or practice area. And they came back with wetting agent treatments kind of a day or two after that aerification. And this is what the turf conditions looked like about a month after that soil wetting agent application. And you can see a month later with that application, there's a couple areas of this untreated area that you can see in the red, green, blue drone imagery, and also the NDVI that are pretty stressed out. Whereas a soil wetting agent coming in after this aerification really helps to allow that moisture to get back into the soil and spread that out more uniformly. And so another application that you might think about for soil wetting agents is if you're going out there with some aerification, and this was core aerification, you might want to think about a soil wetting agent afterwards to really help with getting that moisture uniformly into your soils. So my last anecdote is from Minnesota. This happens to be a native soil on a residential area. This was in 2021 when they had a severe drought. And the individual that was using Tricure on the residential lawn was kind of right on the edge of this sort of orange and red area here. And so they had some pretty tough stress. And so they went out one evening, they applied a 2-ounce rate of a wetting agent over per 1,000 square feet and left another area untreated. They then went out and ran their irrigation for about 45 minutes over the treated area, 45 minutes over the untreated area, came back the next day and looked and pulled a soil core out of each of these areas. You can see the soil wetting agent here. Again, looking at this is very, very much a native soil. The soil wetting agent treatment got the water 3-4 inches down, very much uniformly wetting the surface, whereas the untreated check plot, very, very little water actually got into that soil. So again, wetting agents out there, even in native soils, even in lawn care, even in residential situations, can be really critical and can really help in these situations. So I'm done with all my anecdotes. Let's kind of move on to the nuts and bolts of what's going on in the wetting agent industry right now. So just here in the United States, and maybe you can recognize some of these different wetting agents that I have up here on the slide. There's over 40 different companies at least, and this is probably 2-3-year-old data that are selling wetting agents out there. These 40 different companies just here in the United States are selling over 200 different wetting agent products. And there's over 20 different categories of wetting agent chemistries that can go into these different formulations. And what you read on the SDS or the label doesn't always match up to what's actually in the jug. And so how, as an end user, are you going to actually know exactly what you are adding to your turf? How should you choose the wetting agent that you're actually choosing out there? When do you use one product? When do you use a different product? All those questions are kind of wide open in the wetting agent market right now. So I'm going to dive into a little bit of how do we as industry leaders, how do we as academics and the universities study these products, and what are we doing to really push the envelope to help you as end users to be able to use these products better and really come up with a way that actually makes sense scientifically and practically for you to use these products. So I'm going to kind of go through a number of different marketing or sort of groupings of these different products over the past 20 years. And this is kind of the landscape that was being shown back in 2005. This is a slide from one of the companies that makes wetting agents, and they group wetting agents into these 8 different chemical categories. And they put a number of different products. Maybe you can recognize some of them. Interestingly, we recognized a lot of these chemistries 18 years ago don't even exist on the market anymore. And so there's a lot of things that go into these products. And if your product is not working the way that it needs to work to really resonate with customers, it's not going to last. And so if you recognize products on this list that you're still using, those are probably some of the most tried and true wetting agents that are out there. Not to say that there's not new ones that are coming out. There's a lot of great wetting agents out there, a lot of good new technologies that are coming out as well. But this is really the landscape of those different chemistries. And this is somewhat of a marketing tool. They were trying to argue that there's lots of different benefits or detriments to different ones of these products based on the chemistries of these different products. And so I can take this grouping, and I can kind of come up with my own categorization. And these are some of the different categories that were on the last slide. We can name them on the left. We can classify them as different surfactants. We can give them cartoon structures and show that they're really cool chemistries or new chemistries or completely different chemistries. I can put them into chemical formulations for you and really show you what they are exactly as a molecule and what they look like molecularly. But in terms of what these wetting agents do, if the leading wetting agent surfactant chemistries on the planet, they cannot look at these chemistries and tell you what one of these is going to work on a hydrophobic soil for you to use. And so if anyone is telling you, oh, we have the coolest chemistry out there on the planet, well, I don't really care what the chemistry looks like. What I really care about is what it's doing in the soil. And so when I came to Mitchell Products, that's exactly what I did. I wanted to collect a whole bunch of different chemistries and all of these different products, all of these different chemistry structures, individual components, different formulation mixtures that different companies have put together, and see what they're actually doing in the soil. Because if you don't understand what they're doing in the soil, I don't care about any of these chemical structures. I don't care how complex they are. I want to see what they're doing functionally. And so fast forward to about 2020, this is a publication that was put out a couple of years ago. This is breaking down, based on the label of the product sold in the United States, what are the different sort of mixtures of these different chemistries. And you can see that there's a lot of different variation in terms of what's actually in your wetting agent products. And so this is really interesting to me, because if there's different ingredients in there, you would think that maybe there's something different going on with one product versus another. And so this was actually put to the test. Let's collect a lot of different ones. Let's send them to universities. Let's see what they can show in the field in terms of what's going on. And so this happens to be a study that was published in February 2021 in GCM Online. Some of you may have seen this. This is out of Dr. Baird's research out of UC Riverside. And this is just an image from the study that they published, showing the different products here. There were, I think, 12 different products. You can see this is the untreated control up here. And this was under fair weight conditions and sort of native soils. And you can see certainly the untreated control sticks out. But if you kind of go along these different other plots, they kind of look all the same. And when Dr. Baird really ran the numbers and all the statistics, this is what the data looked like. We're looking at turf quality and all of the chemistries that were used, number 1 to 20. You can read down the list of what ingredients or what different products were tested here. Some of them you may actually recognize. But at the end of the day, you can see here, number 1 was the untreated control. This is the only one that had lower amounts of turf quality. All the other products that were tested looked identical. They were all very, very, very similar. And so this is all very interesting. So we have lots of different, and all the different labels here, they're different ingredients in there. They're not all the same chemistry. And so this was very perplexing to me to see that, well, there's lots of chemistries in these jugs that are different, but they seem to be doing the same thing out there in the field. This is another study out of the University of Florida that was published back in 2018, also published in GCM Online, February 2021, out of the University of Florida. There's a lot of work that's being done on these quote unquote penetrant products out there that are supposed to help water to be released from the surface or move the water down into the soil more readily to increase firmness, increase putting green speeds. And so Dr. Shattuck and Dr. Unruh really put this to the test. And so they had an untreated control, threw 7 different products in there, looked at green speeds, they looked at true firmness, a lot of different measurements in terms of what they were measuring out there on these greens. And lo and behold, when you look at green speed, if you look at firmness, everything looks the same. The untreated control looks identical to all of these other products. And so over the course of an entire year. So this is really very interesting. There are people, I talk to end users, I talk to superintendents a lot. They swear that under their course, some wetting agents, some penetrants are actually having a real big beneficial effect out there. And so at the universities, we're not able to test this. Maybe it's because the green speeds here are 7, 8, 9, and you need to get USGA tournament, US Open, those sort of type of 12, 13 green speeds to really be able to show differences between these wetting agents. Maybe on this type of the physical properties or the organic matter, or the weather conditions here in Florida are different or don't allow these wetting agents to actually work. These are all unanswered questions that we have in the field that are all interesting to me. But at the end of the day, what we need to do is, so far these university studies have shown that all wetting agents look like they're doing the same thing. And that's not going to help you as an end user. And so we need new and better ways to test these products out there in the field, new, better ways to actually test these in the lab, to be able to arm you with information that's actually going to help you. And so, so far I've shown you that these wetting agents all do the same thing, at least out there in a couple of different university studies. Let's take it back to the lab, and then we can go back to the field in terms of the things that I've seen over the past recent time. So these are 3 different chemistries. These are 3 different formulations that are sold out there on the market. These are all wetting agents. They're all used at the same rate here. And so when someone says, or when there's university research that comes out that says wetting agents are all doing the same things, these are commodity products, just choose the cheapest one, that's not correct. These wetting agents are doing really, 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 really different things. We just have to better understand them, develop new tests, better ways to actually test them and understand how they're working. So I'd love to ask the question, and I'll play this video again. My favorite question to play with this slide is whether, let me see here, we'll play it again. Which of these 3 chemistries is the best? If you're a golf course superintendent, which one do you want to use? And I was at a conference about a year ago, and there were about 75 superintendents in the room. I said, who wants chemistry number 1? About 75, 80% of the room, the hands went up. Then I said, who wants chemistry number 2? And maybe 10% of the people raised their hand. And same for chemistry number 3. Well, they're doing really, really, really different things. And you might choose chemistry number 1 in some situations, maybe chemistry number 2 in different situations, maybe chemistry number 3 in different situations. But if you open a jug of these chemistries and you put them out on your turf or on your greens or on your fairways, you have no idea what they're actually doing under the surface. You're just spraying them on the turf. You're watering them in. You're hoping that you are bought a value-based product and it's going to do what you want it to do. But you have no idea which of these different chemistries, based on the label, what it's actually going to do. And so at the end of the day, when I look at this, I want you not to just see this in one dimension, because if you see this in one dimension, you might say chemistry number one, oh, that's the product that I want. It looks like it's really nice and uniform. But what chemistry number one is actually doing is only wetting the top kind of quarter of an inch or less of that turf. It's what I like to call a surface wetter. It just kind of wets and then spreads on the surface. Well, this isn't going to wet that hydrophobic soil underneath. It's going to kind of pull that water off and then find those areas to channel in. Maybe there's situations that you want to do this, but this is going to create hot spots out there on your green. This is going to create hot spots out there on your fairway if this is what's going on. And the chemistries that I've tested with this, that's exactly what superintendents are complaining about when they're using those branded products. Chemistry number three is kind of the other end of the spectrum. The droplet of water goes in. This is what I like to call a vertical wetter. It's pulling water directly down into the soil. It's not spreading out. It's not creating uniform conditions. Maybe there's situations where you want that, where you just want to pull the water straight down and you don't want any lateral movement. And chemistry number two is kind of in between. It's got some downward, really nice downward pull. It's got some lateral pull. It's got very, very strong chemistries in there. I'll show you some data behind that or some videos behind that as well. And so you can really, I like to say the chemistries that fall under class number two, these are going to be your bread and butter, localized drug treatment of localized dry spots, and you're going to get really, really good results in terms of that. Now, not all chemistry is under group number two. Not all chemistry is under group number three, or all products or formulations do the same thing. There's different strengths of these individual components that get put into these formulations. And if you're not testing the hundreds or thousands of products like we do here, to put the right ones into the jug in the right concentrations and the right ratios, you're not going to get the results that you want. And so that's the other thing that you really have to be thinking about when you're looking at these different products. So here are the same three chemistries. I showed you a three-dimensional or a two-dimensional view of them. I'm going to show you kind of the vertical aspect of each of these. Again, surface wetter, chemistry number one, a multifunctional wetter, chemistry number two, downward and sort of lateral movement, chemistry number three, just a vertical mover. You might think that the vertical mover might be able to move water faster through this profile, but if you can see at the bottom of this column, it's not strong enough to wet all that sand like chemistry number two. And so therefore, chemistry number two, when you put more water on top, and this is the same amount of water, for chemistry number two, number three. Chemistry number one never gets to the bottom. It's just sitting there at the top. But if you put the same amount of water in chemistry number two and chemistry number three at the same rates, chemistry number two is able to pull that water because it uniformly wets that entire column faster by an order of about 2 times. It took about 4 minutes for chemistry number two to pull all that water through and about 8 minutes for chemistry number three to pull that water through. So these chemistries are doing different things. And so it's very interesting to me as a scientist. You guys aren't seeing any of this when you're applying the products. So when I am comparing these wetting agents, this is exactly what the test that I want to put them through to really understand how they're actually functioning, what they're actually doing out there. And so when we think about this lateral functionality and vertical wetting functionality, and we think about those 200 products that are out there on the market, we can begin to group them into individual categories. And I haven't tested, I'll be the first to say I haven't tested all 200, but I've tested 50 to 100 of these different products, and we can begin to put these on a graph. Whereas if you have lateral functionality, only lateral functionality, but really good lateral functionality, you'll kind of move to the right side. But if you have no vertical movement, then it's going to be really low on the chart. And I call these the surface wetters. They have very good lateral functionality, but they have very little or to no vertical movement of water. The other end of the spectrum that I showed before, these are chemistry number one. The other end of the spectrum was chemistry number three. These are what I classified as the vertical wetters, or chemistry number two. And maybe you recognize some of these different chemistries out there. Maybe you thought that these chemistries were doing different things than they actually are doing. But in the lab, in the testing that I have done, these are the groupings where we see these products really falling. Grouping number three is what I like to call the diluted products. These are products that are 25% active, 50% active. They're not going to have as much sort of bang for their buck per ounce because they're 50% water. You're getting, when you're buying some of these products, you're getting shipments of water, or 50% or more are coming through with that. And they just don't work as well. And so the last grouping is what I like to call the multifunctional chemistries. There's a lot of different products in this grouping. Each one of them has different ingredients that go into them to make them what they are. And so some of them work better than others. And so you can kind of see the relative rankings or where they kind of fall in this graph in terms of where they are. And so you might think about using these different products in different ways, depending on what the weather is. Is it raining? Are your greens soft? Are you having a lot of localized dry spot action or activity out there on your greens already, or your fairways? Let's look at the weather. Is it going to be hot and dry for the next 2 weeks? Well, maybe you want to put an application or different ratios of a couple of these different products together to get the effects that you want out there on your greens, instead of just throwing, oh, I'm going to put 6 ounces of whatever product that I have because that's what the label says all year round. Well, you probably don't need 6 ounces of all these different products from April all the way to November. You probably can get away with lower amounts of these products on the edge months. Or I'm here in New Jersey, in Florida, in Texas, and Southern California. You need these products all year round. But just suffice it to say, use this like an integrated pest management type of program. You're not going to throw a fungicide out there if there's no fungicide pressure. We'll do the same thing with these wetting agents. That's kind of the start of the thinking. I want to plant that seed because we're going to come back to that when we start talking about how do you actually use these products? How do you write a prescription for your wetting agent program out there for your course that you can individualize, that you can really dive into and really hone in your course conditions to what you want to actually achieve. So here we go. Let's write our prescription. So when I think about writing a prescription for my patients, so I still see patients 1 day a week over at the hospital, I need to understand what's going on in terms of recognizing a disease. Once I recognize a disease, I have to figure out, okay, what drug do I need to use to treat that disease? And then I need to know the drug function, the drug strength, how much does it cost? How well does it work? What are the side effects of it? When I understand all of those things and I think I have the right drug, then I can write a prescription for my patient. And so I can write that prescription, and for my patient, it's not, I'm going to write the prescription and see you later, I never want to see you again. No, I'm 3 months, 1 month, however long I think it's going to take for that drug to work, I'm going to bring them back to my clinic. And then I'm going to see, did the drug work? Are you having side effects? All those sort of things is what I do in the doctor's office. And so these are the same things that I want you to start thinking about as well. And so after that prescription, you're going to monitor the progress. And so if you think of a wetting agent as a drug, which I like to think of because I think it is a drug, it's treating a symptom, it's treating a disease, and maybe it's not a microbial-based disease, or maybe it is a microbial-based disease that localized dry spot happens from. And I'll show you some data in a couple of slides, or at least some anecdotal experience that we've had, that it functions a lot like a pest or a disease. And so if we're treating a disease, let's think about it as writing a prescription. And so when we think about writing a prescription, let's choose the right function. And so here's 2 wetting agents. And again, this gets back to whether they're surface wetters, whether they are multifunctional wetters, whether they're vertical wetters. On the left, this happens to be a vertical wetter. On the right, this happens to be a multifunctional wetter. And you can see they're doing different things. The vertical wetter on the left, it's just moving water mostly downward, whereas the one on the right, this is moving water really very well downwardly, but also creates really nice uniform playing conditions. We talked at the beginning, you want uniform conditions out there in terms of wetting hydrophobic soils. That's where all of your water is going. That's where your nutrition is going. That's where your integrated pest management program products are all going. So these are really key things to really think about. So when you're choosing a drug, choose the right function. And this is another kind of view. If we cut those Petri dishes in half, apply those same products, this shows where the water is moving. So the vertical wetter on the left, really moving most of that water downwardly. On the right, the water is really moving sideways, but also downwardly as well. You can see that those multifunctional products that move water in 2 directions are really creating much more uniform conditions. That's what we're going for out there most of the time on the golf course, especially when we're talking about localized dry spot. So choose a wetting agent that really creates uniform soil moisture. The next thing that you want to do is you want a product that's strong, or you want a really good product. And so if you have 2 products and one's a weaker product and one's a stronger product, you probably want that stronger product. It's going to last longer in the soil. It's going to overcome that hydrophobic condition a lot better. So here, again, on the right, we've got a multifunctional wetter. On the left, we've got a vertical wetter. On the top, that's a droplet of water. You can see the multifunctional wetting agent. It's going to pull that water into the soil much, much faster than that vertical wetter. That water drop on the top, that'll evaporate before that actually infiltrates into the soil. That's how hydrophobic these sands are. So again, really looking for the strength of your product in terms of what to do. So I showed you sand, and we can measure this between all those 200 products that are out there on the market. We can also do the same thing with looking at hydrophobic peat. And so we're looking at pretty major differences in terms of wetting hydrophobic sand. Major differences between different products that are sold out there on the market, one from another, in terms of how well they're able to uniformly wet that hydrophobic organic matter. These are really important things. If I'm seeing these differences in the lab, just imagine what type of differences that you can see out there on the field. The field studies are really hard to do, and comparing products, as you'll see, are really, really tough. And so we'll really rely sometimes more on these lab testing to show these product differences than what's going on out in the field. But as we understand these field studies better and better, I think we'll be able to see much, much more differences out there in the field too. So let's talk about these field studies, because field studies have been going on for three decades at least, maybe 4 decades. And we've learned a lot about wetting agents, but we've designed wetting agent trials very, very similarly for a long, long time. And I'm going to argue that the way that we design these trials have impeded our ability to say that one product's better than another or different than another. And so in the next kind of 5, 10, 20 years, I think we're going to be able to get you information that's really going to show these products are very, very differently. So when I came into the industry 4 or 5 years ago, this is the trial design that had been used for the last 2-3 decades. This is all of the different treatment plots were contiguous. There were no borders around them. The only untreated borders are outside of the treatment plots. And we had very, very few control plots in that kind of light green. And so that's kind of the that you can see on the right, on the left here. And on the right, you can see that this is kind of in the heat of the summer. This is done at the University of Arkansas. They have some of the worst localized dry spot that I've ever seen at a university. And in the heat of the summer in August, when the localized dry spot is supposed to be really bad, our trial didn't look all that bad. There were some areas on the border. Yeah, the borders look bad in some areas. There's pretty high disease pressure in some of these areas, but a lot of the areas in the middle were almost protected from localized dry spot because it couldn't get in there because whether the wetting agents were working too well or whatnot. What I found really interesting from this trial is that the localized dry spot started on this left side of the sort of treatment plots and started to move up, started to move down, started to move in. And this is where we get back to what is localized dry spot? How does it occur? What's going on? And it's almost behaving like a disease. It's those contiguous areas, those areas adjacent to where a localized dry spot occurs, that's going to be more prone to the development of localized dry spot. It's almost behaving like a disease spreading from one area to another. So I find this really interesting. Is there a microbial component to localized dry spot development? Potentially. Is it just that the localized dry spot is a seed and that seed kind of grows over time, almost like a crystal growth? We don't really know. And so those are some interesting things that hopefully with time we'll be able to better understand this. So when we put this to the test, I put out 2 plots here, 2 treated plots, one on the left, one on the right. I like to ask this question, which treatment worked better here? And it turns out that treatment number 2 is actually an untreated control. Right in the middle of this wetting agent plot, or the wetting agent trial, there was no localized disease pressure around this plot, so it never had the chance to develop localized dry spot. This treatment number 1 was actually on the corner. You can see of this treatment plot. You can see horrible localized dry spot out on the edge. That localized dry spot is starting to creep in here, but you can see the majority of this plot is well preserved with a wetting agent treatment. And so if I'm going to choose to roll the dice with an untreated control versus a wetting agent. Well, if a localized dry spot happened in the middle of this treatment number 2, it would have taken over this whole plot. Whereas this plot, although it's stressed because there's such high severe localized dry spot disease pressure, at least you have a wetting agent down there. At least you're getting some moisture in the soil. Otherwise, that whole plot would have been completely dead. So one of the problems with these field trials is the design of the trial didn't allow us to test whether a treatment worked or not, because if the untreated control looks better than the treated side, we're not testing anything for the past 20 years. So we went back to the drawing board, and in 2020, we came back and designed a completely new trial where most of this trial is blue. And the blue is the untreated area. The darker blue is the borders. The light blue are the control plots. The wetting agent plots are in white. And what we did here is we used the same wetting agent and just used them at different weights. How granular, how specific, how sensitive can we be to see differences between these wetting agents, a single wetting agent at different weights? And you can see we got much better uniformity in terms of the wetting agent, the localized dry spot distribution across the plots. So our trial design is definitely working. You can even see down here in the right side, it's almost like a 5-face front of a die. This is exactly what we're looking at or looking for. Localized dry spot pressure around all the plots so that we can really dial in and see when you have equal disease pressure, how do these products actually work? And this is the data. You can see that the untreated control really lost the turf quality very quickly. When we have 1 ounce per 1,000 square feet, it does okay. The turf quality is under just above 6 and a little bit worse than 2 ounces to 6 ounces. But when we're looking at 2 ounces per 1,000 square feet versus 6 ounces per 1,000 square feet, we're still having trouble trying to granularly change or show that these products are different. When I see these in the lab, 6 ounces is way faster than 2 ounces when I'm doing these lab testing. So our sensitivity in terms of picking up differences between products in the lab is much better than in the field. But we're really driving this forward in terms of trying to figure out how are these products working differently? How are they behaving in the field? And can we show the differences that we're seeing in the lab? Can we actually start to see them in the field? And I think we're on the cusp of being able to do that. And here's some data to suggest that. This is done in 2021, again, down at the University of Arkansas with a whole number of different wetting agents. There are 4 different wetting agents at different rates and so on and so forth. You can see down here in the untreated control plots, most of them were very, very severely affected. And then we have wetting agent 1, 2, 3, and 4 here as well. You can see these different wetting agents also had different effects. Wetting agent number 1 didn't work quite as well as wetting agent number 4. And it's interesting because wetting agent 3, wetting agent 4, these are the multifunctional wetting agents. And wetting agent 1, wetting agent 2, these are the vertical wetters. And so it's interesting, and do also note that the vertical wetters were put down at 6 ounces and the multifunctional wetting agents were put down at 4 ounces. And so not only are we seeing that the multifunctional wetters are doing better, they're doing better at a lower rate. And so we're on the cusp of being able to show that these functionalities that we're showing in the lab are truly having beneficial effects out there on the turf. And what I didn't show you, which is in the upper left-hand corner, this treatment right here, this is that surface wetter. And so if you have a surface wetter out there and you have severe localized dry spot in a sand-based root zone, the horizontal or the surface wetters, they're going to do really poorly. You're going to have hot spots all over the place. So I am running out of time, but I want to just bring back this slide. When we're thinking about writing wetting agent prescriptions, you want to choose the right drug with the right function, with the right strength. And as we start to map out these different products out there, I hope that we are able to bring more information, not just from our lab testing, but also true testing from the field that really shows you how these products are working differently. We have 200 products out there. They're not all working the same. How do you choose as a superintendent which product that you really want to choose out there to use on their course? It's going to be partly how much does it cost, but you also have to take into consideration what's its function, how much active ingredient is in there, how is it working in the soil, how is it working out there on your turf. So a lot more that we have to understand with these wetting agents, and I think we're going to have a lot more fun in terms of trying to figure this out over the next 15, 20 years. I'm not going to belabor you anymore with this, but again, think about this wetting agent as a prescription. Don't just throw 6 ounces out. Monitor progress. You can likely save money with some of these top multifunctional wetting agents by cutting back on the rate, depending on where you are, or get longer longevity out of them. So really important things to be considering. And I am out of time. With 1 minute left, I'm going to pause here. I've been doing way too much talking. Rachel, Lindsay, I'm happy to answer any questions from the audience if there's any out there. But thank you again for your attention. Thanks for being here today.
Thank you so much, Lane. It looks like we have one question that came in. It said, curious where water quality comes into play with wetting agents. Is testing and or treating the water recommendation before prescribing wetting agents? Have you tested wetting agent results against or in conjunction with magnetic products like Max H2O?
Max H2O. It's a great question. So the water quality is absolutely going to affect your turf. It's going to have different effects than what we're talking about here in terms of hydrophobic soil conditions. The water quality is going to impact how much salt goes into your soil, how does it change your pH. Many of you are likely or potentially dealing with reclaimed water, high bicarbonates, high salts, high in a lot of different ions. Those ions are going to accumulate in your soil and are going to cause problems for your turfgrass if those turfgrass cultivars are susceptible to either high pH conditions or high salt conditions. And so choosing your turfgrass cultivar, adding soil amendments, whether it's lime, whether it's gypsum, whether it's an acid product, these are critically important to maintaining quality water, but they're not going to have so much impact in terms of hydrophobic water infiltration. Those ions are not impacting what's going on at that surface coating that's creating the water repellency. And so really super important. So there's 2 products out there, and if I'm correct in this, I think that Max H2O is one of those products, and Oars is the other product out there that claims to have benefits in terms of kind of taking that coating, that organic coating off the surface of the sand. It's claimed ORS stands for Organic Acid Removal System. And so just in the name of ORS, and the same thing is used in the marketing of Max H2O, that these products are able to take that organic coating off of the surface of the sand particle to overcome that hydrophobic conditions. The data's out there. I believe it's from the University of Missouri, Dr. Chi, who has done a lot of this work. When you dig into the reports from a scientific perspective, when you look at the amount of organic acid that they are actually detecting from the flow through from these columns, there's really no organic matter coming off of them. These products are not doing what they're saying they're doing. If they were doing what they're saying, and you wouldn't have to apply them monthly. And that's because it takes about a year or 2 for a new green to develop that organic coating on the surface of the sand particles that imparts that hydrophobic conditions. And it'll just keep on going up over time. And so if these products were truly dissolving those organics, flushing them out of the soil, removing those organic particles that are creating the hydrophobic conditions, you wouldn't have to make monthly applications. You wouldn't have to reapply them, but that's not the case. Check out their labels. You have to apply them once a month, once every other month, at the same rates of all of these other wetting agents. They're doing the same thing. It's a marketing claim. In my perspective, it's purely a marketing claim in terms of what they're pushing out there. The chemistries are very, very similar in terms of the block copolymers that are listed on their SDSs and labels. And so from my perspective, from the data, even though there's some data out there to suggest maybe they're doing something, from a scientific perspective, I have not been convinced that they're doing what they're saying. But great question. Other questions out there?
Yes, we have 2 more that came in. One was, do these wetting agents affect different types of grass differently, i.e. St. Augustine versus zoysia?
Yeah, so I'm going to say that indirectly wetting agents are going to have different effects on different types of grasses. And so they're not necessarily going to work differently on your grass, but what I would say is that your grass is going to have different effects on your soil. So one grass might produce a lot of organic matter, another grass might produce less. The root exudates from these different turfgrass cultivars are likely to be completely different. And so it's just like the color of our hair, the color of our eyes. Every individual is going to have differences in terms of all those things that what we do. I might have different amounts of pigment in my skin than other people. It's going to be the same thing with these cultivars as well. They're going to have different root exudates. They're going to have different depths of their roots. All of those things are going to impact your soil water repellency. How quickly does it develop? What's going on under the soil? All of those things are going to be impacted by those different grass cultivars, and whether it's warm season grasses, cool season grasses, whether a turf grass is drought tolerant or less drought tolerant, all of those things are going to be impacting how a wetting agent works, whether it works. That's why there's so much information that we as scientists in this wetting agent field, we have to go out there and begin to tease apart these differences and understand them a lot better before we're able to answer that question to give you a better idea of what you should be doing for these different cultivars out there. We're just scratching our heads in terms of trying to figure out, does product A work better than product B or differently than product A than product B? When you start taking it out to different soil conditions, different grass types, there's a lot of work that we have to do in terms of trying to understand exactly how all those different things behave. But absolutely, I would be surprised if they don't have differences out there in terms of how they're influencing the development of soil water repellency.
Alrighty, and this is the last question as well. Do these wetting agents change effectiveness with different pH levels?
So great question. So some of these wetting agents out there are charged wetting agents. That charge will help them to be able to be dissolved in water, will give them some hydrophilic or water-loving qualities, but those are called anionic surfactants. There are very few anionic surfactants that go into these wetting agent products. Not to say that they aren't out there, but the bread and butter block copolymers, reverse block copolymers have no charge to them. And so because they don't have any charge to them, they're not going to be influenced by pH. And so the most of the wetting agents that are out there are going to do the same thing, regardless of your soil pH, regardless of the water that's out there that you have, depending on what the pH is of your reclaimed water or irrigation or pond water, whatever you're using out there. Most of them are going to be able to behave very similarly with the range of pH that you're seeing and you're using for your irrigation or spray equipment.
I believe that is all the questions
Awesome.
at this point.
Great. Well, thank you very much for your questions. This was excellent. I hope you guys learned something out here while we were talking. Really appreciate your time again, and thanks for having me on.
Thank you so much, Dr. Weaver. Talk with you soon.
Thank you.
Absolutely. Take care, everyone.